got a 50% submission rate is what Bryce said, acceptance rate. So it was a good turnout for submissions this year.
Yeah. Okay, well, at the top of every episode, I'd like to read a piece of feedback. This was actually in response to a tweet you sent out, Jason, talking about your post-CppCon class, which is going to be on Constexpr, right?
Yes, some shameless self-promotion for the conference for myself here.
Nothing wrong with that. So it's Taylor responding to your tweet saying, Constexpr isn't something I've had too much of a chance to play with as I've started converting a C code base to C++. That being said, it's something that talked about a lot on CppCast that I want to learn more about. I'll have to see if I can talk my company into sending me to CppCon, which, yeah, highly recommend trying to get your company to send you out to some of these conferences.
Yeah, if I can just spend one more minute with the shameless self-promotion aspect
Go for
of this.
Yep.
I speak to people that come from two different standpoints. I say, well, Constexpr lets you do stuff at compile time, and people are like, we don't do anything that can be done at compile time. And after like 5 minutes of talking with them, I convinced them that they're wrong. Yes, everyone has stuff that is known at compile time. Or sometimes I mention it to people and I give some brief explanation of what can happen, and they immediately like look at their coworkers and they're like, we know exactly where we're going to start using this yesterday. Mm-hmm. So everyone has something that can be done at compile time. They are not currently doing at compile time. And if performance is a concern for you, well, if performance is not a concern for you, you're probably not programming in C++. So if you're concerned about compile runtime performance, do more stuff at compile time. Come to my class.
Yeah.
But then on the flip side also, just of CppCon here, lots of stuff going on, right? Everyone needs to sign up. Come to CppCon, volunteer. Their call for volunteers is out. And I am organizing the field trip for CppCon, which I don't think I've mentioned on the show yet, have I?
I'm not sure if we've talked about that. Is there any like details you want to share with that now?
This is
the pre-conference outing, right?
It's the pre-conference field trip, yeah. So we're going to Casa Bonita.
Okay.
Which is known by many people from South Park. And it is a ridiculous Mexican restaurant. It is a real place. It's not just something on a cartoon. It is not known for having good food. It is known for being an interesting place to take tourists. And I figure lots of people watch South Park. They'd be familiar with it. So we should give that a go. And then right across the street from that is an arcade that's got just a ridiculous number of classic arcade games. So it's one price, get in, and it's unlimited gameplay, and lunch is included, and the bus ride from the Gaylord and back.
Okay. Sounds like fun.
Yeah. You should come.
All right. Yeah, definitely plan to. Okay, well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Tyler Ang-Wanek. Tyler has been developing software professionally for the past 3.5 years. He works as a senior developer at Axosoft on the GitKraken team. His work primarily shifts among developing native node modules for use in GitKraken, architectural work for code and APIs around GitKraken, and developing new features for it. He is the creator of the node module Node Sentinel File Watcher, NSFW, a native file watcher written for GitKraken that has made its way into Atom and VS Code. One of his major accomplishments includes taking leadership of the open source native node module NodeGit. After much hard work on the NodeGit repo and within the community, Tyler joined the leadership group for libgit2. Tyler, welcome to the show.
Hey guys, thank you for having me on.
Yeah.
Can you just describe briefly what this NSFW node module does?
Yeah, absolutely. So one of the first things that I did working for the GitKraken team is my team lead at the time, he said, we really need to get a file watcher into GitKraken. And the JavaScript around file watching right now just doesn't cut it. It's too slow when it reacts to file events, and it really just chugs the main event loop in JavaScript and can slow your entire application down when you're responding to file events in the main thread. Especially, excuse me, in a Git repo where there are tons of files, just absolutely tons of files. So anytime that you're checking out or switching branches, any of that stuff, or even pulling or pulling, you're going to run into massive massive file events, right? So what NSFW does is it is a native file watcher, so it has an implementation of file watching in Linux and in OS X and in Windows, which uses the operating system provided file watching APIs, runs that on its own thread, and is able to batch those file events into kind of manageable chunks that can be sent back to the main thread and responded to in the UI.
So that's like if a file's changed, if its timestamp is changed, like any of those? Okay.
As many of those as we could cover. However, I got to tell you, developing a file watcher for all three operating systems, every operating system's different, extremely different. It's amazing what doesn't work in one platform, which works really well in another. What one platform provides, another one won't even provide. For instance, like with Linux, we had to write our own recursive data structure, which would walk the tree, the file tree, and build handles to watch every directory in that tree, because there's no native recursive file watching provided by Linux. Whereas in OS X and on Windows, you can just set a flag when you're starting the file watcher, and it's recursive. But don't get me started on Mac OS, because it's got its own problems. Its file system doesn't really do nanosecond, or I guess sub-second time resolution on, or its older file system didn't do sub-second file resolution for some reason, and it also likes to group file events into like a bit flag, or and they keep coming through. So you get like added, then you'll get added modified, then you'll get added modified delete, and you have to either keep track of that or go ask the file system, is this true? Is what you told me, is that actually what's going on? It's a nightmare, and everyone's got their own way of developing those APIs. So Windows is different, Mac is different, and Linux it's different.
Well, it caught my attention because I used to use QFileWatcher on a project that I was using, and I reached limitations with it. I don't even recall exactly what now, but basically had to do some sort of workaround, even though I had a cross-platform tool provided to me, because all three operating systems would do things differently. I would run out of file handles on Windows or whatever,
Yeah, on Linux in particular, the iNotify subsystem that has a hard limit for how many file handles that you can actually have, or how many file watches that you can have, and that's somewhere in like 500,000, which actually isn't enough.
Right.
That's not enough, but that's what we deal with. So actually some future work there is I need to go back and implement polling in that particular area, so that we have a fallback mechanism. But for now, it seems to have done enough work to get the job done. So there hasn't been too much of a need to go back on that yet.
I like the idea that you batch them together. That sounds really helpful for response times and stuff in your GUI.
Yes, and that's one of the major advantages of using NSFW. There are some actually really powerful file watchers written for Node using Node's APIs. One of them is Chokedar. That would be my major competitor. Chokedar is mostly written in JavaScript. However, they acknowledge that macOS has the worst file watching system, so they have their own native module developed for watching files in OS X. But the key, they actually have more features than we have, but their performance suffers in comparison to what we have. And since performance is often what we want in a GUI application, we're going with ours, even with a few less features, because we can cover whatever we're missing in Chokedar in JavaScript pretty easily.
Right.
Okay, well, we'll start digging more into the work you do on GitKraken, but we got a couple news articles to discuss first. Feel free to comment on any of these, Tyler, okay?
Okay.
Okay, so this first one is a post on the Fluent C++ blog by Jonathan Baccara, and this was expressive C++ template metaprogramming. And I really love this article because I often find template metaprogramming to be very difficult to read through. and he goes through an example of how you can break it up and make it a lot more readable while still being, very powerful TMP code.
Yeah. I have to. Oh, sorry. Go ahead, please.
I'm actually very interested in an article. I like what I've always wanted to get a little deeper into template metaprogramming.
Mm-hmm.
We do code generation in NodeGit to generate C++ to wrap a libgit, which is a C library, and export that functionality in a JavaScript. And a lot of those written in a JavaScript templating library somewhat similar to handlebars. And I would love to remove some of that in favor of template metaprogramming.
So you have a JavaScript templating library that is generating C++ code.
Yes.
Okay.
Wow.
Haven't heard that one before, right?
I don't think we have, actually.
No.
Yeah, it's fascinating. But the art, yeah, it really, I liked his approach. It really helps kind of see or get you like thinking about, okay, what does this mean? Because when you first see it, it's like, well, how do I read this? How do I get better at template metaprogramming? How do I write it more fluently?
I think I'm slightly ashamed to admit that the first example, I'm like, oh yeah, I totally know what that does.
I'm not as up to speed as you, I'm sure.
Like, wait, that's not what I was supposed to say at this point. But he actually does a great job of explaining like what void T does. And to be fair, void T does feel a little bit like a black box to me. So I like how he renamed it later. But since I know Jonathan listens to this podcast, I'll point out I don't think he actually explained Sphinx anywhere.
Not in detail, no. I don't think so.
And I think that's kind of an important piece of this. Like, why does this whole thing work at all? Mm-hmm. And it's because of the magic of Sphinx.
Yeah. And the one thing I'll point out, even if you are familiar with template metaprogramming and you can read that initial example and know what it's doing the way you do, Jason, I mean, I feel like his suggestions are worth applying anyway because it gets you more reusability the way he breaks things apart. Right?
Yeah.
Yeah.
Absolutely. I've been down at his very bottom example. His like template type names finally have, some of them have like meaningful names. Type name attempt, class expression, right? It's one thing I try to convince my students of. Like if you're writing a template, we're so used to seeing template type name T, template type name U. Give them names. Like if all of our variables were named IJK, like,
right. Okay. Next article we have is Bring Your C++ Code to the Web. And this is on the Coding Tidbit blog, and it's all about getting started with WebAssembly using Emscripten. And I thought it was a pretty good kind of intro, kind of get your hello world running and telling you what the steps are you need to do to get it set up on Windows using WSL if you don't have a Linux box. And yeah, I mean, it was pretty basic, but I thought it was a good intro.
I feel like Tyler should have something to say about this article because it seems more up in
do
his
you do much with WASM?
Here. So we don't do enough with WASM yet, and it's partly because there are some performance concerns when you cross that barrier from JavaScript to the WebAssembly, transferring data. I know that they're kind of being processed by V8 at the same time, but when you're there's just like a little bit of latency when you jump into WASM from JavaScript. At least a friend of mine who I think is part of the TypeScript Arizona meetup. He actually was giving a demo on TypeScript not on TypeScript. Oh, actually, yeah, it was on TypeScript where you can directly compile TypeScript to WebAssembly now, which is, isn't that crazy? Yeah. I'm going to have a lot of tidbits about a totally different side of the community for you guys. But you can compile TypeScript to WebAssembly, and he just kind of wanted to give an example of that. But one of the concerns that he was able to demonstrate in his talk is that it's not there is a latency concern when switching over to WASM. So maybe for projects that are purely WASM, or as it improves, we'll see less and less of that. And another concern that we've had that has prevented us from jumping into WASM is threading support. And I believe threading support's on the way. I believe Chrome has the feature there ready, but I haven't had time to evaluate how well that works.
I can't even imagine, like, if Node doesn't currently natively have threads in it, trying to make something like that multi-thread capable and a giant code base like that after the fact is so extraordinarily difficult. Be a huge project.
Mm-hmm. It's actually interesting to. Are you guys familiar with any of the low level of Node? I am, just because I live it, and so Node.js is actually founded on two one C and one C++ project. So it is built using V8, which is Chromium's JavaScript interpreter and runtime for JavaScript. Right. And then it's built on top of libov. And libov is a event loop library written in C. And it basically manages I/O operations like network, file operations, and all of these things. And it is actually responsible for what you think of as JavaScript and Node as single-threaded, because the JavaScript itself is running on that one thread, but a lot of I/O, network, all of that stuff is actually done off of that thread in libov's thread pool and is requeued on the event loop when that information is ready for JavaScript to run with. It's kind of fascinating, but whenever I hear people say that JavaScript isn't multi-threaded, or Node.js itself isn't multi-threaded, I always think about, well, sort of. There is actual threading to it, but it's not where you think it is.
Right.
Actually,
no, please go ahead.
When we get an opportunity to jump into it, a lot of the work that I do is native. So we write C or C++ modules that are able to take advantage of libov's threading support, as well as all of the I/O operations that it provides for Node.js, which means that we can run batched I/O methods or routines on other threads, ship that back to JavaScript, and it just kind of package it back up and hand it back, and the UI can respond to that. So there's some really cool stuff that you can get into that's not JavaScript and Node.js, which is strange.
Right. I just have one comment about this article before we move past it. At the top, the author says that they're using WSL because VirtualBox only supports 32-bit guest OS. I've been using 64-bit guest OSs in VirtualBox for like 10 years. So I went and double-checked to make sure they didn't somehow remove 64-bit support, which they did not. I think it basically, because they rely on the virtual machine extensions and modern CPUs, I think it basically requires 64-bit host. Okay. And so therefore it just passes the 64. Yeah, so it definitely, VirtualBox definitely supports 64-bit guest OSs. It's definitely an option if you can't use WSL. Right. When you're following this article.
So if you're not on Windows 10 and you want to go with VirtualBox instead of WSL, you definitely can.
Yeah, you could use Windows XP for this experiment if you wanted to. You might have to go back a rev or two in VirtualBox, but it would still work.
Right.
But don't let my concerns with WebAssembly off-put anyone if you're listening. It's coming along, and it's actually going to be the future of web development at some point. It's going to take over just because WebAssembly, once you're in WebAssembly land, is quick. And that's something that the web needs.
So the web will become C++ compiled to WebAssembly, running in JavaScript on a JavaScript interpreter written in C++.
It's possible. I don't know. But one of the things that I've always thought is best tool for the job, right? Right. And sometimes it's going to be C++, sometimes it's going to be Rust, sometimes it's going to be C. It's just going to depend on what you're working on.
Right.
One more comment about WebAssembly being the future. I know, C++ was the first language to kind of get a compiler for WebAssembly, and now you mentioned that TypeScript apparently can do it. I don't know much about it, but I know Microsoft and the .NET team also has a thing called Blazor, which is to get C# into WebAssembly, I believe. So I guess the more languages that hop in the WebAssembly pool, the more it'll advance and become a real thing you can use. So the more the merrier.
Definitely. Yeah, one thing that I really want to see happen, Firefox is actually ahead of the game when it comes to debugging support for WebAssembly, where you can actually debug source code in Firefox, but you can't debug that source code in Chrome. You can only debug the WebAssembly right now. And yeah, so that's another pitfall for Electron users since we're based on Chrome. We don't even have that support yet, which is unfortunate.
Okay. And then last article we have is, I think it was just a few weeks ago that we mentioned Meeting C++ 2019 and how Jens made it so you can now vote for the tracks or vote for the conference talks.
That everyone can. More to
Everyone can. Even if even if you haven't bought a ticket, you can go in and vote. And he's announced what the first 11 talks are going to be based on that voting. And these are going to be the talks for the main track. And definitely some familiar names here. Bryce Adelstein-Lellbach is giving 2 of these talks.
Two of the top 10, yeah.
Yeah, John Kolb giving one of them. I know I recognize some of these other names, but he's only giving the last names here, so I don't recognize all of them.
Yeah, Yositas is an author. We've never had him on, but he's well known as well. Those are the main names I recognize immediately. And I'm assuming that's John Kolb.
I'm assuming
so. Other Kolb.
Right.
Adelstein-Lellbach? Pretty sure that's
Bryce. Yeah, so Bryce giving a talk, one on modules are coming, another on the C++ 20 synchronization library. John Kolb giving a talk on modern template techniques. And yeah.
Really interesting, yeah.
I'm looking at that coroutines talk. I'm actually pretty interested in coroutines. We had some support for coroutines land in JavaScript through like generators, which build iterators with kind of like that yield keyword that allows you to, pass values out and receive values from another, from whoever's driving your iteration. And with libraries or with that like power, we've actually been able to get some odd threading support or to split up our main thread in JavaScript using coroutines, almost like a threading library. I'd like to see what you can do or what you can dream up in C++ with coroutines.
It does sound like in the last episode we discussed, there's still some questions about the C++ coroutines keywords and such. We'll see what exactly shakes out in Cologne, which is what? When is that?
Next
this week?
week. Next week. Yeah.
Okay.
Okay. Well, we already made a couple references to the project you work on, Tyler. Can you tell us more about GitKraken?
Yeah, GitKraken is an Electron application that tries to make Git easy. Git can be pretty opaque. We've all heard about the directed acyclic tree before, or the directed acyclic graph from XKCD. But really, it is hard to work with Git. There's a lot of command line things that you need to learn. There's a lot of hidden magic when it's in the command line. And even if you're a power user that uses the command line, you still have tools for displaying the graph and navigating commits, like Maggot. And we think that we can simplify it a lot with a really great graph to show you how your commits work together. Try to simplify that. And yeah, we're also kind of opinionated. There's some things that we don't support specifically because we think that they're not great concepts in Git. One of them, and I don't know if anyone wants to hear this, is I think that a headless state in Git is a bad state to be in general. temporary branches are way more powerful. And temporary branches are a better state to be in because there's more Git operations supported in a temporary branch than there are in a headless state.
Okay.
So, we have opinions, but I think we make a really great tool. It's fast and easy.
So do you disallow getting into a headless state from the GitKraken perspective?
We don't typically. We don't expose the ability to get into it, but of course we support it.
Right.
So if you were in a headless state, we work just as well as the command line would. We just don't support getting into it very easily.
So if the user does something on the command line, you'll reflect
Yes.
that accurately.
Absolutely. So, we're pretty close to one-to-one with what you can do in the CLI. It's just some of the things we like to hide or abstract from users because not always the strongest things. But that's not really even a critique of Git. That's more of just what's important when you're working with Git, and that's it's paying attention to your commits, it's paying attention to your diffs, and it's seeing other people's work and being able to cooperate. So we want to make that part the easiest.
Okay.
So you mentioned that GitKraken is an ElectronJS app, and we were, asked to, get one of you GitKraken developers on the show because someone saw a blog article who's a listener of the show saying, hey, these guys are writing an ElectronJS app and starting to move it into C++. So can you maybe start off by telling our listeners a little bit more about what ElectronJS is?
Yeah, so it's actually, I love explaining Electron because first the community was like, I love JavaScript. Google's doing great things with JavaScript, so let's take JavaScript from Google Chrome, get rid of the browser, right? Get rid of the browser and build a server-side JavaScript, right? And then at some point, someone was like, well, I love Node.js. I love the server-side JavaScript. Why don't we give it a UI that you can work with the server-side JavaScript with? And they're like, I know a perfect tool for that. Let's get the Chromium web browser. And that's the best explanation I have for Electron is they built server-side JavaScript, and then they recoupled the Chromium experience with the JavaScript experience again, just in a different format. It's fascinating.
Okay, so essentially if you're running an ElectronJS app, you're kind of running a somewhat stripped-down version of Chrome?
Yeah, you definitely have Chromium running on your machine. And you have a lot of parts of it, but it is stripped down. There's a lot of stuff in Chrome that doesn't make it into Electron. Some of the benefits, though, of doing that, not just to, it is kind of wacky to think about how it came about. And, a lot of programming, I think, has a great story, right? But with Electron, some of the benefits are that it has a lot of awesome cross-platform support because it's based on Chrome. So
Right.
There's a lot of libraries and functionality that's built into Electron that you need in most desktop applications anyway. So it comes with a big toolbox. And of course, that's also a valid criticism of Electron, is it does come with a big toolbox. So it's a bigger application to begin with.
But you can just render any CSS, HTML, whatever in there?
Yeah, any HTML, any CSS, and you have a lot of the tool set that you get with Chrome, and you have a deeper level of control with Chrome, but you also have all of the power of Node.js and all of its ability to interact with the operating system in ways that regular websites can't operate with the operating system.
Intentionally.
Intentionally, right. That's fair enough.
Okay, so how exactly are you, starting to leverage more C++ and maybe go over why you started making that move towards C++?
So GitKraken, and I think this may surprise you, but a lot of GitKraken is actually written in C++ right now. And we talked briefly about NodeGit, which is that JavaScript library that generates a bunch of C++ to wrap that C library, that's a lot of that's probably, there's a lot of larger companies out there are going to laugh at this, but it's probably 150 to 200,000 lines of code, right, that we generate.
Generated code. That's a fair bit of generated code. Yeah.
It's a fair bit of generated code. It's libgit 2 is a big project, and we like to re-export as much of that as we can. And I'm actually just going to prefix this. Many people might be wondering why we don't use something like FFI for integrating with like a C library. And that actually exists. FFI does exist, but FFI also has performance concerns. A Node FFI project runs slower than if it was compiled, if it was just like a regular compiled binary, or if it was a native add-on for Node.
So I'm only vaguely familiar with FFI. Can you explain that for a moment?
Foreign function interface. And so if you have a library that's compiled, it can export symbols that are, and it can export the symbols, and foreign function interface is a way for you to interact with that library, even though it wasn't written in your language, the language that you're using. It wasn't compiled for whatever thing that you're working on, but you're able to kind of call into that and hook up to some of those functions. For Node FFI, actually, one of the tougher things is JavaScript is a garbage collected language, and the FFI package that would help you compile that is, I don't think, adequate for a complicated library like libgit2, which has its own methods for freeing structs, and the way that Node FFI ties those structs into like the garbage collection system would not be correct. There's caching mechanisms going on in the background. So how do we get the C++s? Well, we had C++ in our application to begin with. And we started with all of that generated code providing the ability to call C code from libgit2. And we wrote a lot of JavaScript, which was just calling out these functions. And these functions are asynchronous, mind you. So we talked earlier about an event loop in Node.js, and how libov does have some it has threading support with it, but it's kind of hand waved away to the JavaScript user. So you're writing. So the libgit has a bunch of these, or NodeGit exports libgit functions as async functions if they were to do like I/O. So you're going to check out or push. That's a network operation or a file operation that's going to be blocking somewhere, right? So that will be run on a thread in NodeGit, and you'll have kind of a handle to that, or a callback in the event loop, where you'll get the result of that operation later in the event loop, and then you can continue working. So we had all this generated code, and this generated code kind of when you have that many asynchronous functions and you're writing tons of business logic for doing Git operations, and you only have one thread to process events for the event loop, you tend to bottleneck the event loop.
Okay.
And you bottleneck it in a big way. And I think one of the best examples for this is we had another project which was doing a deep dive on a folder structure to see where all of your Git repositories are, right? So we can display what Git repositories a user might have. So originally we had a JavaScript implementation of this. And what's interesting is that you would asynchronously ask for what directories or what's in a directory, and then you would get a result back from that, and you go over that, and you make calls for each one of these, and then you would asynchronously go dive into that, right? Well, say something else is happening. So now you scan for directories, you get that list back, right? And something else is happening. So instead of immediately going and checking what things are directories and what those directories have, you wait. Someone else is processing right now in the main event loop. So you can't respond to that, and you can't continue the algorithm. Now, it's still responsive, right? But that's paused because users doing something else, or there's something with higher priority happening in the event loop. So that algorithm, which is just trying to search through directories, is actually not, if you looked at the time it took when it was actually processing, it's about the same speed as it is synchronous. But if you factor in all of the other things that are happening in the application, it's so much longer because it's had all these pausing points. It's paused so many times. It's almost like it's like thrashing a CPU, almost like it gets paused to allow other things to happen. And the overall process of delivering the results of the full directory walk is way slower. And that was something that we had identified early on. So we had always tried to tackle certain problems that take up that we want to be responsive, but take up too much time to be processed in JavaScript. And we've always tried to move those things into C++. So coming back to NodeGet, right? We have a lot of JavaScript that's doing similar things to the directory walk. So we're going to go get a list of all the commits, right? But that in libgit's exported as a walk on the SHAs. So it's going to give you a bunch of SHAs back in a rev walk. And then you're going to have to go look up all the commit objects for those SHAs, right? So you do that 2,000 times, right? But say you're also looking for references and trying to figure out what references are tags, what references are branches. And you've just got this massive asynchronous, you've got two massive asynchronous operations that are kind of contending for the same thread's attention to complete their goal. But they're both being slowed down because they're synchronizing it in the main thread.
Right.
So for us, what I wanted to do is we have libgit, we have NodeGet, and we have a feature in NodeGet which allows us to write C++, which can just be tossed into the generated code wherever we choose, and can kind of become part of the compiled side of GitKraken. And so say we take that commit walk and we want to look at all these commits. Well, we can write one method in C++ that runs on a separate thread, and on that separate thread, or in the thread pool rather, in the thread pool it's going to do the rev walk, look up all the commits, and then give you all the commits back in one shot. So now how much async work you did is you called one function and you had one callback, and it had the results or it didn't have the results. Of course, if there's an error, right? But that allows the main thread to do other things or to coordinate other work. And so for us, C++ is almost like the obvious choice because we already have such tight integration with C and C++ that we might as well expand in that territory when it makes sense. And the nice thing about being an Electron app is Electron provides a lot of like awesome utilities that just make programming super easy and flexible. And it's this really cool hybrid approach that we have right now, or that we're expanding on, where we can write things that need to be performant or quick or non-interfering with the main thread and on our thread pool. And we can, when we need to do things that the user sees, when we need to do just the small touch-ups to that data before the user sees it or interacts with it, we can handle that in JavaScript and show that in HTML, CSS,
right,
and work with that in like a really clean way. But that's kind of what the driving force for C++ in GitKraken is that Node has native support for C++, and it has it's not any other language that's like directly supported by Node.js besides JavaScript and C++. And it's just because the JavaScript engine that's running in Node.js is V8, and that's all C++. And libov, which is it's C, but it's compiled by C++ compiler. It's you have it's already like a great place. It's already ready for it, right? It's just kind of saying, hey, this is the right move.
So it kind of, I mean, hearing what you're talking about sounds like a complicated build process to me. You've got generated C++ code, you have to compile node modules, and you've got the JavaScript, and is this difficult to manage all of these pieces?
So we have kind of like a Unix approach to a lot of this, and that makes it easy. So, GitKraken with its JavaScript primarily is all by itself. It's primarily focused on getting Electron in and getting JavaScript working. We have NodeGit, which is actually a completely separate project that compiles on CI, ships over there, does its own thing, and we don't have to worry about. Well, I do actually. I manage a lot of things, but I guess I kind of shield. I'm kind of like a barrier. A lot of our programmers can work in JavaScript where there's a lot of it can be really easy to work in JavaScript, and that's nice. But we also have just this other area for compiling that. But when you're building locally, it's occasionally you'll come up with, we're switching compilers, so everyone needs to update from VS 2012 to 2015 before you can rebuild GitKraken, because somewhere deep down, one of our packages now uses 2015 and not 2012.
Right.
Or we switched from Clang back to GCC, surprisingly, and that was because our CI servers, the version of Clang available on them wasn't. It was kind of causing crashes. However it was being compiled, it was crashing in Linux, and that was unfortunate.
Right.
But you got to make do with what you have. So yeah, long story short, yeah, it can be complicated, but I think we've done a lot to manage the complications and to isolate each system into something that compiles by itself and can just kind of integrate seamlessly.
So do you ever at any point have your JavaScript developers be like, this thing that I'm working on is just too darn slow, I need to toss it over to the C++ developers, or vice versa, have the C++ people be like, it'd make way more sense than throw it over the fence to the JavaScript people?
So we're trying not to, so I may have given off the impression that we have totally distinct. I am trying to ramp up everyone to not only be JavaScript, but to be involved in the C++ as well.
So they can all make a decision.
Yes. We want to be properly polyglot, and that's hard, especially C++ is a big language to learn. There are a lot of intricacies, and it's hard to be an expert, and I'm not one, right? And there's just so much out there, and it continues to improve and expand. And so, unfortunately, due to just restraints that or constraints that we might have, we don't get to use some of the newer C++ features just for, we want to target a minimum build for Linux, say, right? So we may not be able to get to C++ 17 or 20 anytime soon.
Right.
So yeah, we're trying to get everyone to be able to switch back and forth, and I think I was really happy with the performance work that we did for GitKraken on our last release, because I saw some people that were just they largely remained JavaScript developers for a long time, even though we had the C++, and I saw them say, this is what we need to do to make it performant. And they really stepped up, and they jumped into that, and they learned what they needed to learn, and they improved some of our algorithms in GitKraken, and that's awesome. And so I hope that we can just keep on that trajectory.
That's very cool.
So question I had is, it sounds like you've been working on this for a while, and you now have a nice mix of both JavaScript and C++, and you're trying to ramp up the C++ even more. If you were starting a brand new app and using ElectronJS, how much effort does it take to start leveraging C++?
So it's actually not too bad because, well, let's prefix this. Documentation in Node.jip could be way better. And are you guys familiar with JIP?
Generate your project?
That's right. Generate your project. It was a Google-backed, kind of like make file system where you could, it generates your project, right?
Mm-hmm.
And you can build it for Visual Studio or, gosh, why am I blanking on this? Xcode, or, it could generate make files. Now that's been replaced in Google by Ninja, right? So they're using Ninja for Chrome now. And that's, I wish we could use Ninja, but we're still stuck on JIP and the Node land. But grievances aside of documentation in JIP, JIP is like Node.jip is a first-class citizen, and what Node.jip does is it allows you to write binding files, and binding files are just a description of your what C++ files have to be compiled and how they need to be compiled, and that also helps link it with V8 and libov and get it to be a dynamic library that's ready to be loaded by JavaScript. So there's actually really decent support to build C++ right alongside your JavaScript. And at a small talk that I did for an Electron meetup in California, one of the takeaways that I had was if I were to start a new Electron project, I would try to have a JavaScript source folder, but I would also try to have a C++ source folder where just right there in your Electron app, you have the means to just start to write a new feature right there, not another project, as part of just GitKraken or that Electron app, right?
So even if you don't have immediate use for it, you would start with it from the beginning.
I would at least leave space for it.
Right.
So I would make sure that there's a nice little cozy corner for when we do need it. And I think as you grow as a desktop application, you have to think you are a desktop developer. And a desktop developer has so many more resources than just JavaScript in front of them. And there's tons of other things that you can do at the operating system level or at like the library level that other developers have open sourced that would be at your fingertips if you kind of open the door and jumped into that.
Is there a good tooling story with evaluating the performance of some of these changes? Like, are you able to really measure when you switch over some component or feature from JavaScript to C++, how much it improves?
Yeah. So one of the early things that we worked on was migrating. I talked about like reading references earlier, and so we just did like a small refactor of that. We have timing systems in the JavaScript, which allow you to see like how long did a function take to run. So even across the asynchronous nature of it. So we would time these functions there, and then we would time them after they've been written in C++. And what we care about is how long does it take to get the results. We don't care how long it takes to run the code in C++. We care how long does it take to go out to C++ land and come back to JavaScript and be responsive. And so that was the metric that we were looking at. And with that metric and refreshing references, we saw like a 2 to 4 times improvement on a cold start and an 8 times improvement when GitKraken's already running. And so what that means is just when GitKraken's booting up, there's a lot of stuff going on. There's a lot of threads involved in getting GitKraken started initially. And, when you have a lot of threads, it's going to slow down in other ways, right? But once it's started and up and running, it doubles the performance of the cold start, which is really cool.
Okay, so while you're trying to make sure that you've got this, round trip time that you expect, it sounds like having a reproducible performance test suite would be relatively difficult.
Yes, actually. So we have been paying attention to one of our other Electron app developers, Microsoft. who is building VS Code. And VS Code, I think, if you really look at it, it's one of the fastest Electron apps out there. It really is. They've done great work optimizing it. And the VP of product here, Hamid, went out to a conference where Microsoft was talking, and one of the talks that they gave is how did they optimize for performance, and also how did they measure performance. And one of the things that they mentioned is they have a terrible laptop, and it is connected to CI, and whenever a new build comes out, and it's just an awful old laptop, might have like a hard drive, at low RAM, terrible CPU, but they run VS Code and check the startup time of VS Code 10 times on every build. And they make sure that at least one of the startups meets their expectations.
At least one.
At least one. So at least one of the startups of these startups on this awful, terrible laptop has to meet certain performance expectations. And so we have an old laptop now that's hooked up to our CI that on new builds can check that same condition and tell us, are we still starting up quickly, which was one of the major things that we were focusing on for performance last.
I've never heard of that technique before. I'm going to have to... I mean, it sounds slightly fragile because eventually that old laptop, it's going to die.
Fair. There's always more. There's always other old laptops.
You can actually, I've got two.
Every year, a new laptop is old.
Yes. If you need any extras, just let me know. I will mail them to you.
So yeah, it is an interesting way to measure performance, but it's also, it actually gives valid feedback. It is actually really good feedback to see that on this old system, it's starting up that fast. And if it's starting up that fast on an old system, it's almost guaranteed that it's going to start up fast on a newer system. And so that's why I think the metric, while strange, is good.
And is it then with a known repository or something?
Yes, it's always the same repository. The system's always running the same things. It does nothing else except wait for a request to test.
Right.
Yeah.
That's kind of cool.
Yeah.
Think about that. It doesn't work in the realm of cloud computing.
No, I wouldn't say so at all. But for desktop development, I think it's not too bad. Now, that's startup time, but we still, I don't think we have a great infrastructure for automatically testing other aspects of the performance of the application. But a lot of the things that make the app feel snappy are also things that make the app start up fast, which is a lot to do with like reading data and getting data ready to display. And so they're kind of intermixed. So if one's fast, typically the other remains fast and snappy. So I can't wait for the day when that's not true, and we've got to think harder. But it'll come.
Okay. It sounds like there really are a lot of ElectronJS apps out there that developers are using. Like there's GitKraken, which you might be using for your source control. VS Code, which has become a very popular editor. I think Slack is another ElectronJS app that a lot of developers use.
Yeah, but Slack gets a lot of flack for using 16 gigs of RAM while you're on a chat session.
Well, I think Slack
is that a feature of ElectronJS, or is
it doesn't have to be?
Okay.
But it is easy to get there if you're not careful. Though I'll tell you, because we use some C and C++ ourselves, we always have the option to footgun ourselves with memory management. I've done it. We've all done it, right?
Right.
Yeah, it happens. But with JavaScript, it's harder to control. And so in some respects, you have to be really careful about, because it's garbage collected. You don't want to get the garbage collector in a state where it's like, well, we're looking at that guy, looking at this guy, looking at that guy, and now we can't. Now we're in a cycle, and guess what? We're around to stay. So yeah, it can get memory intensive, but we try to pay attention to that.
Well, it's been great having you on the show today, Tyler.
Yeah, thank you guys so much for having me.
Yeah, thanks for joining us.